Hi guys, welcome to another video by TechSubs.
In this TechSept, we are going to discuss some applications of neural networks that deals with images. First, let's look into image classification.
In image classification, a model is supposed to recognize what's in an image and assign a class to it, like this is a cat and this is a dog.
In 2012, AlexNet came out and it was considered a breakthrough since it basically gave birth to a deep learning boom. Even though neural networks have existed for decades, AlexNet is known as the first to use them to get better results than traditional statistical methods on ImageNet dataset. It used convolution, max pooling, and dense layers.
VGG improved on accuracy by making the network deeper. ResNet used residual blocks to mitigate the problem of vanishing and exploding gradients. As the name suggests, MobileNet was designed to achieve decent results on mobile devices. Therefore, model size had to be kept to a minimum. VIT used a transformer and could achieve 85% plus accuracy. Also, there are some other newer models like Coca and Basic L that have achieved better accuracy.
In object detection, the main idea is to identify what objects and where are those in a particular digital image such as photos or videos. So what's new in object detection? It is important to point out that there is no one algorithm better on all situations of object detections. It depends on the use case and the application. For example, Beta RCNN shows the best results for pedestrian detection. One of the popular neural networks on object detection is YOLO, which interprets as you only look once, and this is a part of the single shot detector family. On the MS COCO dataset, the YOLO version 7, which is the latest version, provides a faster and stronger network architecture with more effective feature integration method, more accurate object detection performance, a more robust loss function, and an increased label assignment, and also increased model training efficiency compared to other predecessors.
Semantic segmentation is the task of assigning a class label to each pixel in an image, and it has numerous applications in fields such as autonomous driving, medical imaging, and robotics.
State-of-the-art models for semantic segmentation typically use a convolutional neural network architecture, which is trained on a large dataset of labeled images. One popular model is the U-Net, which has an encoder-decoder structure with skip connections between corresponding layers in the encoder and the decoder. This allows the model to retain fine-grained spatial information while also capturing high-level semantic features.
Another notable model is DeepLab, which uses dilated convolution to capture multiscale information and a global pooling layer to incorporate contextual information. DeepLab also employs a fully connected conditional random field post-processing step to refine the segmentation results.
Recently, there has been a trend towards using transformer-based models such as Vision Transformer and Swim Transformer for semantic segmentation. These models rely on self-attention mechanisms to capture long-range dependencies and have achieved competitive results on benchmark datasets. However, they typically require more computational resources and training data than CNN-based models.
Instance segmentation is the task of simultaneously detecting and segmenting each object instance in an image. State-of-the-art models for instance segmentation typically use a combination of object detection and semantic segmentation techniques such as Mask RCNN and ULACT to achieve high accuracy.
Mask RCNN extends the faster RCNN object detection model by adding a branch for predicting an object mask in parallel with the existing branch for predicting class and box offsets. This enables the model to generate accurate segmentation masks for each detected object instance.
On the other hand, YOLACT, short for You Only Look at Coefficients, uses a single shot detection architecture to simultaneously predict object class, box, and mask for each instance. The model employs a prototype-based approach to generate instant masks, where a set of prototype masks is learned and combined to form the final segmentation mask.
Okay, now you guys have a basic understanding about image classification, object detection, semantic segmentation, and instance segmentation with neural networks.
You're dead. You crazy son. You're dead.
If you guys enjoyed this TechSubs, please like and share. If you have any suggestions, feedback or questions, don't hesitate to comment.
We are planning to bring more useful content from different tech fields in the future. So, to stay tuned, please subscribe and hit the bell icon. See you soon.